It's so cheap too, and it
Look at the lighting!
Oh my god.
Regrets
Close
on
up.
friendship choices.
That's so awesome. My God.
Makeup.
Hello once again, internet. So finally I got some lighting in the dorms. So it is currently, let's see, 11:06. So it's 11:06 at night. It's almost midnight, and I finally just got some lights to bounce off a white wall to reflect back my face. So it's almost like I have my daylight again, but it's not actually the daylight, of course. And on top of that, I finally fixed the Z-banding on the 3D printer. I mean, look at this. So when it comes to white filament, I've always been able to see artifacts more prominent than in any other color. And obviously you can see that I have pretty bad Z-banding all around this print. But in this one right here, I finally don't have it anymore. So I officially have gotten rid of the Z-banding artifact of my 3D printer. So the Leadscrew upgrade kit from Robo 3D has been out of stock for quite some time now. I finally took it upon myself to buy the Leadscrew stepper motors from Amazon, and I decided to make them work for the Robo 3D. Now the guide screws that come off of the ones that I bought off of Amazon don't have the same hexagon shape on the couplers, so you need to 3D print a piece that goes over the guide screw that gives a hexagonal shape that matches the coupler that you used to have on your old lead screw. And I have a small recording on how I went to go make that, and I'll show you that right now. So I'm currently 3D printing another one. This is what the model file looks like. I'm gonna show you how I designed this from the ground up real fast. So the first thing I did was made sure that I was in inches. So I used the polygon tool, and I measured the biggest diameter to be 0.58 divided by 2. So that's gonna be the radius of the actual polygon itself. The inner circle that the new couplers ride on is about 0.4 inches. And then the bottom diameter of the new couplers was 0.85. So what I did was I later on went around these, and on every single intersection in this circle I did 0.1. After all the circles were put in, I used the extrude tool on the outer circle. I extruded that by 0.1, and then I measured the distance I needed to extrude of about, I think it was 0.8. And then I got this model right here. Of course, all I have to do now, export STL, OK, and then I save it as an item. And then when I open it in Cura, and this goes straight on top of the couplers that came with the lead screws that I bought off of Amazon.
So those didn't even come with it? Like those weren't a Robo 3D attachment? You just put them on there?
No, I had to model something to put them on there.
Oh, that's really cool.
Yeah, I 3D printed an adapter to make them work for the Robo 3D printer. Then I put them on the 3D printer.
That's awesome.
I know, isn't it great?
That's awesome. I didn't know that.
So cool. It's amazing.
It's amazing.
It's amazing.
It's amazing.
This is the piece that turned the circular guide screw into a hexagonal shape that fit on top of the X carriage that the 3D printer already uses. And what was the best thing about this is that I only had to model this once. It worked first try, no issues. I was really excited about that. Very rarely do I ever have a 3D model that I 3D print and it works for its intended purpose the first time.
Does that little face, is that in your bed? Yeah, this guy?
Oh yeah, I think you're even in it too.
Right now?
Yeah, well your head is at least.
The one right here, is it?
Yeah, kinda. That's Austin if you didn't know. So the results of the lead screw upgrade are spectacular. Not only do I not have Z-banding anymore, but the entire zeroing process and the speed of the printer has increased tremendously. Now, if you're really excited and want to see the results of how the 3D printer moves, you can feel free to click right here. And I'll shoot you to the end of the video. If you want to see the process in which I took to actually install the lead screws on the printer, just keep watching. I'm gonna show you this later, and you are clearly in the shot,
Currently?
crouching the entire. No, not right now, but like when you like ducked, you're just in the shot, crouched. I'm like looking at you, like, all right. So I just 3D printed the new piece. What's really cool about these, and I thought was really fun, is if you actually hold the coupler and release the stepper motor, it'll actually spin all the way off the axis. Anyways, so the piece that I 3D printed and model designed, that gets shoved into the piece that you buy online. Now they fit really well together. If you really want to, like I said, you can 3D print the holes as well, and then you can drill through and actually tap a screw, but there is no way that this is going to prevent this from spinning around this axis as well. So this is the same geometry as the couplers that are currently on the lead screw. With the addition of these new lead screws, the Z-banding should go away. So we're gonna hope that works. I have already taken the top off, of course, the lights, pieces, filament, things and stuff you should know if you're taking the 3D printer apart. My carriage is completely modular, so I can take the entire carriage off the top. There we go. Hey Robert, can I get a 2mm Allen key?
Yeah.
Alright, so I'm officially gonna remove these. I don't really care if I'm bending them anymore, because I got new ones that hopefully work. Man, if they don't work, I'm gonna be very disappointed. So, I do need this piece still, so don't just go and throw your motors or throw your lead screws away. You're still gonna need the component that goes around and clamps to the hexagon. So keep that around. Alright, so now that I've removed this much, I'm gonna flip the printer. Robert, may I please have a screwdriver? There we go. And let's see here. We need to remove those. So all we're going to do for this is we're going to take a regular screwdriver, and there are 4 bolts that are 4 screws that hold the corners of the stepper motors in place. These are the wires that came with the motors that have the new lead screws built into them. They don't have a pin for the other end, so I'm going to solder these to the stepper motors that are currently on the printer. And because I need length still, I'm going to cut the wire at the motor end, and I can just solder these later. So Austin's currently playing zombies right now. Don't worry, you can get the audio on and everything. But so I went to go solder the wires together for the stepper motors, and it turns out that the pin configuration is actually different than the ones that are designed for our 3D printers. So I went to go test the wires out a bit, so I kept having to switch the wires back and forth after I had already soldered them. The way you can remove these pins is by taking a blade. Use a razor blade, and you go inside the little pins right here. And instead of cutting, desoldering, and resoldering all the time, because once that's done, try not to break the connection again. But what you do is you just kind of put the razor blade in there, make sure you're safe and not adding a lot of pressure to cut yourself. And you actually can get the pin to come out. Let me see if I get close up on this. This is the side right here that you would put the blade into, a little pin right there. And when you're ready to put it back inside, all you do is make sure that the pin side is up that can grab the back. When you put it back in here, it'll just fall back into the pin connector. You'll hear a snap and the wire will get stuck in there. So you need to change the configuration from blue, red, green, black. That's the original configuration the stepper motors are found in. And you end up changing it to red, black, green, blue. That's the one that I found worked for me. Now I can finally install the model into the system. One thing that I've already done with the other stepper motor is that this, because I already redesigned the piece, I need to get this piece off. And I redesigned it so it had the same dimensions as the coupler that was already on the lead screw. So all you do is loosen it, and you should be able to pull it out. And then for the new model that we designed, let me get this off here real fast. I'm loving these. So for the new model, these will fit right into the hexagonal shape because they're the exact same dimensions. And all you have to do is just tighten them with the screwdriver. So now that this piece has the switch and everything back on it, I can put it back on here, and it works just fine. Of course, you need this removed to put it through the actual printer itself. I was just showing you how to put this back onto
There we go.
the connector. You're gonna put this from the bottom through the terminal. You wanna make sure that the pins that come outwards are facing the Arduino board so that you have an easy way to hook up the connections. And make sure you just have a screwdriver handy. And you're going to just screw the motor corners back into place. There'll be 4 screws that hold the stepper motor in place. You want to just make sure that the stepper motor goes in evenly and straight. So, I just finished using the LCD controller to change the max speed around. I haven't set the steps for millimeters, so it's currently way off on calibration. But to see it in action, I'm going to do an auto home real fast. And so it works and everything. They're definitely not grinding, they're not moving back and forth, and so they look good. But right now I'm at 0 on the Z-axis, and if I go to 20 millimeters, that's what it thinks 20 millimeters is right now, almost completely on top of the carriage.
Oh my god.
So I need to change the steps per millimeter so that 1 millimeter is actually 1 millimeter on these new coarse threads. So I've been playing around in Marlin a little bit, and I actually got to change the code up. Well, they sound elegant. They are amazing. But this is what it looks like right now. I have the speeds at like 25, 30-ish. And so if I gotta reset the printer real quick. So I'm gonna do a G28 real fast, and I'm gonna have the printer home all the way down to the bed. And it's crazy how fast it zeroes now. And this is all the way from the max top at 200 millimeters. So it's running great. Now I'm gonna do a test print with this and see if my Z-banding's finally disappeared. So hopefully that's the case. So without a doubt, it is definitely possible to buy the Leadscrew upgrade kit from Amazon and get it to work on your Robo 3D printer. And to recap on the steps you need to 3D print the adapter, install the lead screws, make sure you change the stepper motor coils, calculate the new E steps per millimeter, and then you're done. Z-banding's gone. It's delicious. Now the quality yielded from this process is extremely effective. I highly recommend doing this. If Robo 3D finally releases the Leadscrew upgrade kit, I recommend you buy those, but the Leadscrew upgrade kit from Amazon is on par with what I would assume they give you. Sadly, the ones from Amazon are only 250 millimeters. They're advertised as 350 millimeters, but that is, of course, not correct. But I only ever need to go to 200 millimeters on the Z-axis anyways, so that's not a big issue on my end. Maybe for others, perhaps. And apparently, Robo 3D has already released the Robo 3D R1 Plus, which actually already has this Leadscrew upgrade kit built into the design stock. So this feature comes out from the manufacturer, which is really cool. So if anything, I highly recommend, if you are interested in the Robo 3D printer, be sure to get a Robo 3D R1 Plus so you don't have to do the Z-banding upgrade, because you shouldn't have Z-banding in the first place. So these are what the new lead screws look like. They have an extremely coarse thread pitch in comparison to the old lead screws, which look like that. So obviously with the larger pitch, you also have the added benefit of an extremely fast moving Z-axis. Oh, this is so awesome. I love this. So I had to change the firmware because the Z-axis was limited at 5 millimeters a second. So I went inside the G-code and I changed the Z homing speed, I changed the Z max speed, and I also changed the Z manual movement speed. So when I move it with the LCD controller, I have the ability to move this at a pretty fast velocity. But I mean, I'm already at 100 millimeters. And now, I'm at 132. It's crazy how extremely fast the lead screws have made the 3D printer. And one of the best things about this is how fast it preps for a 3D print. And this is my favorite part right here. The speed at which the auto bed leveling works is ridiculous now. So, I hope this video helps you install your lead screws, whether you got them from Amazon or Robo 3D. If you have any questions about this video or suggestions for future videos, make sure you leave your comments down below. If you like this video and want to see more like it, make sure you click that subscribe button. So the lead screw upgrade has not only rid of my Z-banding cancer, but it has definitely increased the performance of the entire 3D printer. It is something that I absolutely, completely, undeniably, oh shit, I forgot the word.
What? Recommend?
Recommend! And thanks for watching.